Today we are going to look at empirical and molecular formulas. Empirical formulas mean from data, and we get these calculations from actual lab data, mass data we do in the lab. To calculate, step 1, convert grams to moles of each element. We're using the 1 mole equals relationship to do that. Step 2, divide all moles by the smallest. And then step 3, write the formula with the numbers from step 2 as subscripts. We also write the formulas with the metals first. So for example, in lab we use 32.0 grams of Br and 4.9 grams of Mg. Step 1, convert each gram to moles. So we have 32.0 grams of Br. I'm going to do 1 mole on top. And the molar mass from the periodic table for Br is 79.904, which gives us 0.4005. Then for the 4.9 grams of Mg, we're going to use 1 mole over 24.305 because that is the molar mass from the periodic table. And we get 202 moles. I think that's 002. Step 2, divide each by its smallest. So for Br, we will do 0.4005 divided by 0.2002, and we get roughly 2. If for Mg, we do 0.2002 divided by 0.2002, and we get 1. If this came out to be like 1.8, we round up because we want these to be whole numbers. So round to whole numbers. If it is like 2.5 or 2.49, somewhere around that range, or any 0.5, it doesn't have to be 2, it could be 1.5 or 0.5 or 5.5. You're going to multiply by 2. But if you do this one by 2, and you have to do this one by 2. So we're going to do both of them. Whatever you do to one, you have to do to both. In this case, they work out pretty evenly to be 2 and 1. So step 3, we're going to write it. The metal goes first, and the easy way to tell which one goes first is if you look at the periodic table, just start on the left and work your way to the right, and whichever one you hit first, that's the one that goes first. So Mg is in the second row, so it's going to go first. Mg, this 1 we could put down here, but usually we don't write a 1 in place. And then we write Br, and then this 2 is going to go down there. So our actual formula is MgBr2. For molecular formulas, this means how they really look, or the real formula. To calculate, there is a step 0. So you have to have the empirical formula first. So if I give you data, like I give you this data and then the molar mass of the molecular formula, you first have to go through these steps to figure out the empirical formula, and then you can put it into this to do the molecular formula. So have to have the empirical formula to start. And then you make a rather large box. But we're going to use this chart. And this row is for formulas. This row is for molar masses. This is our empirical column. This is our factor column and our molecular column. So let's go with an example at first. So you have NO2 is our empirical formula, but we say that the molecular formula is 92 grams per mole. This and this you have to have. So these have to be given to begin with. Now remember, I could give you this and this for you to do these calculations to get your answer, and then that would go into this box. Then step 1, find the molar mass of this one. So this is 46.005. Step 2, we need to find the factor. So this times something equals 92. So if we're looking for this, we're just going to divide these two. So you have 46.005 times some number equals 92. You can just put an n in for number. To get this by itself, we're going to divide both sides by 46.005. You have n equals roughly 2, and we want this to be a whole number. So again, a whole number. So 2. Step 3, use the same factor. So if we multiplied the molar mass by 2, we need to multiply the formula by 2. So times 2. And then step 4, apply factor. So this 2 means that we have 2 of these stuck together. So we're going to do the 2 times the 1 for the n and make it n2, and the 2 times this 2 to make it O4. And that is how you do molecular formulas.